how an engine works. Let's look at technologies Toyota uses in its engines to enhance power output, fuel economy, and emissions control. The more efficiently an engine breathes, the more efficiently it will produce power. Toyota engines incorporate a number of features and components that are designed to help the engine breathe more efficiently. An acoustic control induction system, or ACIS, automatically varies the length of the runners in the intake manifold to maximize the airflow into the engine and provide more usable power throughout the entire RPM range. At low speeds, ACIS directs intake airflow through long intake runners in order to produce ample low-end power and torque. Think of this as taking deep breaths while lifting a heavy object. At high engine speeds, ACIS directs the air through short intake runners in order to generate more horsepower. Think of this as taking quick, short breaths while running. Some manufacturers utilize a single overhead cam, or SOHC engine. All Toyotas feature dual overhead cam, or DOHC engines that allow optimum placement of the valves. Benefits of a DOHC system include enhanced power output, fuel economy, and emissions control. Since the power of an engine is determined by how much air and fuel can be burned in a given period of time, Toyota uses 4 valves per cylinder instead of 2 or 3. This arrangement improves the intake and exhaust performance of the engine over other valve configurations. A 24-valve engine is a 6-cylinder engine with 4 valves per cylinder. Variable valve timing with intelligence, or VVTI, is one reason Toyota cars and trucks develop horsepower and torque across a broad RPM range, or power band. A computerized system changes the intake valve timing to optimize the engine's breathing depending on the conditions. Without VVTI, valve timing is fixed no matter how fast the engine is running. As a result, an engine that works well at high speeds won't perform as well at low speeds, and vice versa. With VVTI, intake valve timing is constantly adjusted, enabling the engine to perform well over a wide range of speeds. For an even greater range of valve control, some Toyota engines use dual independent VVTI, which controls both the intake and exhaust camshafts independently of each other. This provides an even greater range of valve control. The result is enhanced power and torque delivery and greater fuel economy throughout the vehicle's power band. Dual VVTI also reduces emissions as it creates an exhaust gas recirculation effect by overlapping intake exhaust valves. A dual-path exhaust system works somewhat like ACIS, except ACIS maximizes airflow into the engine, while the dual-path exhaust maximizes exhaust flow out of the engine. A second path, or chamber, opens in the exhaust system at higher RPM to help evacuate the higher volume of exhaust, resulting in better breathing with less back pressure. The more efficiently an engine breathes, the more efficiently it will produce power,